Hello. Okay, let's see. Hello, hello. Okay, cool. It's been a long time I'm not streaming. Feels like ages. Hmm. Internet it feels so like. Just wait a minute. Going to talk about the web assembly. I think today I'm going to introduce some WebAssembly. I really don't know about the technical WebAssembly, and I only know about the concept of the WebAssembly. So I think today I'm going to explore the WebAssembly with the Rust and React.js. Maybe I'm going to set a goal, but let's gather people now. I think I'm going to share a little bit about my stream to my Facebook. It skip error. Oh damn, why it's error right now? Come on. Alright, here we go. Okay, so for everyone who's still watching this, maybe you need to know something about the WebAssembly, or you need to set a goal for the WebAssembly. I think let me know on the chat. My God, wait. I still can't share anything on the Facebook. What's on your mind? Okay, cool. Switch the TV and my talk way. Speaking. Okay. Wait a minute. Okay, so I'm going to a little bit my music. Right, okay. So on this moment, I think I'm going to share with you guys about the WebAssembly. Especially we are going to learn it with React. I'm going to tell you about why we are using the React and Rust, and also we are going to set the goal of this learn. So we're going to learn by practice. Especially I never learned about the Rust before, but I knew a basic fundamental of the Rust. Okay, where should I go first? Okay, here is the WebAssembly. Okay, so the basic concept of the WebAssembly, as by told by the Mozilla, um, you know, classic assembly because we want to process everything faster and we want to process everything through the core of the CPU. So one of the goal of the web assemblies is also the to be fast, efficient, and portable, and also be readable and debuggable. Because assembly who wanted to read about the assembly, and then we want to. So there is also an interesting point in here about the keep secure and don't break the web. I think I'm going to tell you guys about the keep secure and the don't break the web later, and we will be focused on be fast. I think this is too small. I think today I'm going to be focused on to be fast, efficient, portable, and be readable and debuggable. That's my point today. So, what is web assembly and why should I use the Rust? So, to talk with the core of the CPU, yeah, central processor unit, you need to be used the almost like middle programming language, and it's supposed to be from to C, C++, and also you can use the Rust. And for the front end, we will use the Node.js or the React.js. Okay, so first thing first, here is why we need the um, how do you call that? The Rust and also the React.js. Let me see. I'm going to draw this on the draw.io. Oh, itu iPhone di. Going to draw the basic web assembly. Um, okay. So basically, how WebAssembly and then the React.js is communicated. Uh, how do you call it? Wait. Okay. So we need this. We need this one file that is called let's say this file is actually the back end to process about the calculator. We called it the call wasm. So we are going to use the JavaScript, right? So we are going to put in here the webasm.javascript. This is like a tools or the library that is can have a capable to read about the WebAssembly file. So what we have on this calculator WebAssembly, so this is actually a basic function. So there is a two variable that can access by the WebAssembly. That a function is actually a simply add, multiply, or divide the number, and it will give back the return of the result of the number. It's simply like that. So the function is like giving of a parameter of the first number, and then the second of the operator, and then the third is another number to be calculated. So here is what it's going to do. The WebAssembly is actually accessing directly the calculator, and then after that the calculator is also will return this to WebAssembly.js, and then we can parse this into our home page. Let's say this will be return the output simply like that. So what do we get in here? The calculator is actually processed directly into the CPU, so it will be much faster rather than we are using the basic JavaScript. But actually, it will be much faster using the JavaScript because it's still on the language. But if you're using the WebAssembly, it will be much faster because it will communicate directly to the CPU. All right. So how do is what it look like to be the WebAssembly file? It will be looks like this. So the first thing first, we have this a simple factorial function that will be return for every the number on it for the number factorial simple number. So the source code, the C source code will be converted into the WebAssembly. It will be looks like this, but there is also WebAssembly what text format, so it will be a simple source code that maybe CPU can read. Okay, let's little bit explore from here. So WebAssembly time abbreviate WASM, right? It's an open standard that define a portable binary code. So it's like a portable binary code format for executable program and corresponding textual assembly language. Okay, let's see a little bit about the history. So it's from the 15, sorry. And the first demonstration was executing Unity Angry Bots in Firefox. Alright. The precursor technology were ISM.js. Yeah, this is the very first technology of the WebAssembly. So this ISM.js is a subset of JavaScript that designed to allow computer software written in language such as C to be run as web application while maintain performance characteristic. Right. Okay. Um, so why people really takes seriously about the WebAssembly? Because if you want to implement im implement anything on the web, like virtual desktop, or you want to make some idea, it will be much faster if you use the WebAssembly. So it will be easy to access over the internet, and it will be much faster because it is built by the WebAssembly. So, for example, what the platform or what kind of website that run on the WebAssembly? So this is a very public website one. So we have GitHub 1s, GitHub 1s. So this is a very basic of the WebAssembly implemented on the internet. I never test about the GitHub 1s. Uh, are those the WebAssembly is pretty secure or not? But here is my point. We can see this from here. Right. So we're going to find the WebAssembly file. Which one? Here we go. We have the VS Code Oniguruma uh, WebAssembly dot WebAssembly. So here is like the example of the WebAssembly that is accessed by the main.js. Uh, and this WebAssembly is hosted on the static GitHub 1s. And every JavaScript in here is actually access the WebAssembly to run this Visual Studio Code IDE on the website. And it will be much faster with the WebAssembly because we never like feel about the laggy on this GitHub one is because it's run on the WebAssembly. Here is, for example, the return. It's just the bit magic number. Let's see what we got if we directly access the WebAssembly. We just need to download this. All right. This file is actually only like 400 kilobyte. We're going to open this with the Visual Studio Code. All right, here we go, the file, and we're going to open this. The file is not displayed in the editor because it is either binary or use an unsupported text encoding. We're going to open this anyway. Reopen edit with text editor. Here is what it looks like on the actually the file WebAssembly. We have like an active file extension with the ISM, so it's supposed to be the assembly file. And then we have this oops, you guys can see this. All right, here we go. Here is for this example. We also have the WASI. Okay, the WebAssembly and then the WASI is actually different things. And WASI is actually WebAssembly System Interface. It is like how you deploy the WebAssembly into the internet, and you can run this secure on the internet. All right. Here is the only WASI, and then for every file in it, it's actually run on the WebAssembly. Here it is. Right, normal file. Can I see any string in here? Wait, we can't see any string in here. All right, so that's it. So the GitHub OneS is actually access the WebAssembly using that WebAssembly this ONIG WebAssembly to run a whole this Visual Studio Code on the running on the web. I don't know how long it's actually run on the new. It's only like 5 seconds to access. No, it's like 10 seconds to reload on the new browser. I'm using this incognito to test the performance of the GitHub OneS. It's actually only took like 10 seconds, and when I access the file, it's really much easy. It's like an usual my Visual Studio Code, and this is how it looked like to be running WebAssembly on the internet. So we have the WebAssembly in here. So where is the part of the WASI? WASI it's like we built this around WASI. So the WebAssembly will be much more secure because the WASI protect the this file, WebAssembly file, so no one can access directly the object. Okay. So we have the history. Okay, we back to the history. So the WebAssembly is actually first announced on the 2015, and they are executing the Unity Angry Bots in the Firefox. So they are running the Angry Bots on the Firefox using the Unity, also the Google Chrome, and also the Microsoft Edge. Yeah, it feels like the browser is actually operating system itself, because in the future maybe the browser will be a lot faster and a lot like different from the web with the desktop right now. Okay, so the project is actually run start from the 2015, and then from the 2017 is actually finished the project, right? So here we go, the implementation. I think I'm going to use no, not this one. Uh, let's find some speaker deck about the web assembly JavaScript, Rust and WebAssembly for the mazes. Yeah, right. Here we go. Hit Stockholm. What? Okay. Uh-huh. Right, here we go. We have this what is it called? The presentation on the internet. I found it on the speaker deck. Randomly, it's created by the Sendil Kumar and February 5th, 2020. And let's see what he got. So he described the WebAssembly as like yet another front-end web framework. Yeah, right. So basically, the JavaScript is actually a high, how do you call it? The high-end programming language. Yeah, and so the JavaScript we can easily understand about the JavaScript because we have the compiler. The compiler is actually making the file can communicate with the CPU. So we have this JavaScript engine is actually uh, communicate with the WebAssembly binary. So we have to file JavaScript to build the website and to build the web apps, and also we have the WebAssembly binary to working with the uh, processing backend, I think. Structured state machine. Okay, I don't know about the RHEs and also the LHEs, and then what is the sum? The I32 probably is like the integer for the 32 uh, byte. We have to get local RHS, get local LHS. Okay, and function add is called. What is that mean by RHS? Let's see. RHS, maybe it's like remote or local uh, site. It's actually mathematic. Oh, okay. So RHS is right hand side, and then the LHS is like left hand side. I'm sorry. A bit. No. Okay, sorry, I'm back. Uh, we have this structured stack machine, and then we have the right hand side, and then we have the left hand side. So I still don't get it, but it's like a get local of every part, and then we have a function is called. Okay, and we have a little sum box in here. Okay, we have a size and load time efficient, right? WebAssembly is pretty size and load time efficient because it will be much smaller file size, and then the load time because the WebAssembly is directly communicate with the CPU. Native speed, of course, made it with assembly. Okay, we have this website that is called made with assembly. Where is it? Made with webassembly.com. Right. Okay, send data with sound. Okay, we have a chirp. A chirp is like a send data with seamlessly over sound. Wireless speaker. Wasm Sudoku solver. We have a SketchUp, Redis, porting Redis to apps with C-lang OASI. We have a WAPM, CD Pound, Air GUI layout, mostly with the AI. AI likes everywhere. Prism built front-end web apps with Ruby. Okay, SQLite. Compile to WebAssembly true. Okay. uBlock origin. Wow. We have a decoder player in here. Okay, I also have another example, best way rather than this calculator actually. Let's say we have the converter. So you know about the converter on the uh, YouTube converter or video converter from any other um, video platform that you want to save on your local machine. It's actually like send your data. It will you will define the video itself by the URL, and then it will send the data on the backend to the backend. The backend will be process this, and then it will back to the user. Um, so there is communicate from the server to client. So if you're using the WASM, it will be much easier because only client to communicate through the WebAssembly. So let's see about this Yogi ogv.js, this one. Oh, there is, it's like a library. Here is some video for. Oh, okay. So there is some like benchmarking in here. They are show the drop FPS and then video decode time on millisecond, I think. Yeah, on millisecond. 3 point. It's like 1 digit millisecond. Okay, so this player is using the WebAssembly. Let's see a different with the native. It needs like 500 millisecond. The much faster with the WebAssembly, and it's a little bit different. Okay, let's see another good tools about this. Oh, we have the theme. Oh, cool. Okay, let's set the goal. I think this is pretty interesting. I don't know if anyone made this with the WebAssembly. How about we made the WebAssembly with like, here we go, web. Hmm. How about we are creating the web assembly with Rust and React.js to build the offline first web application. How about that? I think this will be good. So what about the offline first? What about this? What about this application we are going to make? Let me see. Um, what kind of application that I can run offline and then it also run offline? It's pretty easy. Let's see, how about the, yeah, a simple, that would be good, mas rust+reactjs. Yep. Hey, what's up, Will Arkov? It's been a long time, right? To the application, creating the web application with demo to do application is kind of common. I think I'm going to make a different. Let's see what I'm going to do now. Okay, what about we are going to integrate this with the Bibit, right? We have this Bibit. It's like the my bot that gather every data, uh, every item on the jogjaonline.co.id, alphacart.com, and the click Indomaret is actually still scrapping right now. How about we made a simple website that lists all of this file? So it will only need to sync the data every day. So it only need to sync data once every day. So it can also run this online or offline. Web application, WebAssembly. Okay, let's create the. No one actually know about BBit. I think I'm going to make a general name. Uh, let's create the how do you call, what is called the Jogja Online and Alpha Card actually? The um, item shop, tempat belanja segala kebutuhan Anda. What do you call this on the with the English? A place to shop for all you need. It's classic. Um, let's create the okay, how about like this? Let's create the faster Jogja item groceries list with WebAssembly also with Rust and React.js to build the offline first web application. So we have three main keyword in here. We are going to create the faster Jogja item groceries list. So it will be Jogja item groceries list. And we are going to build this with WebAssembly, also the mix between the Rust and the React.js. And also the last challenge, we're going to make this an offline first web application. Oof, it will be a long project on this March. This is a good project on the March. Let's make this happen. All right. Okay, here, that is our goal. Oh, we have the file converter here. File converter digital. Downloading apps. Okay, yes. Let's see. I'm going to convert some file. Unlimited free online as many as you want. No file size limit. Convert video and image. Yeah. Uh, he really mentioned this with the caption and bold and font size, big font size. There is an unlimited free and online as many as you want. This is actually a common problem with the file converter on the internet because they need a server resource to convert any file. So the problem is comes whenever many people want to convert file, they need to wait. Some people will need to be wait the turn to convert the file. Okay, so they can convert videos and images. So I think I'm going to pick some image or maybe the video. Yeah, the video will be better. We are going to test this with a bigger file. Let me see. So we have this 3 megabyte of file. So we are going to convert this to GIF. Yeah, we're going to convert this to GIF. What? We can convert this to PNG. Like a lot of file. Okay, so I'm using some file that is, the file size is like 3 megabyte. So they need to load the library first with the file size of the 9 megabyte, I think. Okay, I'm going to start this. Here we go. The application is pretty simple. Okay, I'm going to reload this first to check the performance of the file. I'm going to select some file. Yeah, this one. Here we go. That is pretty simple. We have this fmpage core.js. They have the fmpage core.wasm is actually run on the WebAssembly, and then we are going to start to convert this into the GIF. So here we go. It's actually it just oh nice. It's actually just convert immediately by the FMPG by client CPU. So it will be much faster to be processed because uh, the application is actually not using the server resource, it's actually using the client resource. As you can see the bit rate in here. It's like almost like 1 megabits per second, and then but it drops the FPS because you see we are using the GIF file. There we go. Here is the file. We can download this. Where they store the file actually. There is no. It's actually the file itself. We can see. Oh, here we get the image address. Yeah, it's a blob file. File converter.digital. Right. That's pretty cool about the WebAssembly, right? So there is another problem if we built this WebAssembly with some of the private function or some sensitive function that will show some source code or will show some um, credential. It will be much dangerous if people can direct access the function. So we need the WASI to secure that. Okay, let's continue about this. Okay, it's been like 42 minutes and we didn't still code. Okay, I think I'm going to start this using this developer Mozilla rust+reactjs. Okay, so there is two main use cases for Rust and WebAssembly. Build an entire application, an entire web app in Rust. Build a part of an application using Rust in and accessing JavaScript frontend. I think we're going to use the second part. Okay, so first thing first, we are going to install Rust. Okay, here we go. For the WSL. I'm going to update a little bit with this ZT. Hope you guys can see this. Okay. We need to install the Rust. So using the Rust, this install a tool called Rust App, which lets you manage. Okay. We have this Rust C as the compiler. We have this Rust C. We already have this, and then the Rust compiler as well as cargo. We need the cargo. Cargo is like Rust package manager, and then I think I'm going to make some point in here so we can discuss this in the end of the stream. We are going to using this one. Yeah, I already made some simple learning about the Rust actually. Where is it? Here we go. Wasm practice. Not this one. Wasm. Hey, where is it? Oh, here we go. We're going to make this like day one learn. Here we go. So we want to build goal. We're going to make some goal in here. Our goal is like this, okay? And then what next is the next one. Why? Okay, we are going to learn Rust first. So for the Rust, we need the rust as the compiler, and then we need the cargo as the Rust package manager. Okay, what else? Rust package manager, Rust std, Rust library, and some helpers, Rust docs. Okay, all right. So pay attention to the post install note about needing cargo bin dictionary in the system path. This is automatic, but you must restart your terminal for it takes effect. Okay, so the next one we need to install this wasm pack. Okay, going to the document. We open source and then my directory with the rustler. I think I'm going to make a new directory that is called the webasm learn. Right, we are going to install the wasm pack. Okay. Next one, we need to install the wsm pack. We package. With cargo install wsm package pack. Okay, so how the Rust run actually? So it's actually pretty simple, like a common C or C++. So you need to define some file of this Rust, and then you only need to compile this with the Rust C, and then of the source code. Will show some error or something. So there is also some new file that I created in here that is called the to format the print, simply like that. Right, so we already installed the wsm pack, and then we also need the node.js and npm. Right, we have the version 14 for the node.js, and we have the npm for the version of 6. Okay, building our WebAssembly npm package. Enough setup, let's create a new package in Rust. Navigate to whatever your personally project and type this cargo new lib helloasm, created library helloasm. So we need to create the double WebAssembly, building our WebAssembly npm package. We need to create the WebAssembly npm package. Why we need to create that? Okay, let's just keep follow this first. Maybe we are going to get some point in the last of the learn. We're good using the cargo new dash lib, and then yeah, we will using the hello world assembly. Here we go. We're creating the library helloasm. So we have this new structure directory in here. Clear first. We have a new folder, a new directory that is called the helloasm, and then we have a file that is called the cargo toml. Maybe the cargo toml is actually the package manager for the Rust. We are going to get this. Wait. Here is some of the file. They read the git config maybe. We have the edition of 2018. Okay. And this is define every dependency of the Rust. And then let's see the source code itself. What we have is just simply a mode of the test. Okay, I don't know about the mode. Maybe it's actually like a function. So the fn it work is actually a function. So the assert equal is like unit testing to test if the 2 plus 2 is actually return 4. It's simply like that. Okay, we made that. So first we have the cargo toml. This is the file that we use to configure our build. If you have used gem file from the bundler or the package JSON from the npm, It's simply like this. We won't use this test code at all, so go ahead and delete it. Oh, we can delete this. So we're going to delete the src lib rust. And then let's put this code into instead. Oh my god, I already delete this. Okay, let's see lib.rs. Okay, we are going to type this one by one, so we are going to understand every line of code. We are using the use wsm bin gen prelude. So I assume this actually import some library. But what is the wsm bin gen? Okay, this book is about WSM Benjen, a Rust library and CLI tools that facilitate high-level interaction between WSM module and JavaScript. The WSM Benjen tool and create one part of the Rust WebAssembly ecosystem. Okay, so the WSM Benjen is actually a core application, a core library that will be part of the Rust and WebAssembly ecosystem. What is the Rust and WebAssembly ecosystem? Um, okay, there's nothing actually. Oh, so the Rust WSM GitHub is actually a simple. No, they actually get it from here. Pretty cool. Okay, we will continue this with this script. Okay, so we need to define it like WSM bingen. I still don't get it with this function on this method on this Rust. So they will extern pub function alert s and str. But I'm pretty curious now. What is like this part? I think this is a very basic of the Rust actually. We need to Rust hello world. Okay, here we go. Doklang Rust. What does actually? Maybe it's called the type. Suppress all running from the cache which overflow. Okay, it's actually not that. Std library types. No. What is that actually? Like a linter. We need to see some. What is it? The primitive one, custom as not it's not. Okay, how about we Google it first? Rust operator before the function, like this. No, not this one. What the difference with this Rust by example? Okay, that one is actually a Rust by example. Rust macro. Oh, so that is actually a macro. I just remember the macro is actually like this one. You need to define every function there, or attribute or something with the question mark. Is that the question mark actually? No, it's not the acceleration mark. Oh, so oh no. Right. Okay. Oh, we have the notation in here. Lecture and syntax grammar snippet. At the end of simply listing, for example, string, a grammar, a notation are used by a lecture and syntax grammar snippet. It is called the lecture rust. I still okay. What is lecture anyway? Oh, right. Let's see again. Specify the correct name. Okay. Rust semantic obey a past distinction between compile time and runtime. Semantic rules that have static interpretation govern the success or failure compilation, while semantic rules that have a dynamic interpretation govern the behavior of the program at runtime. Okay, so it's actually a rule for the compiler with the macro defined in here. The compilation model center on artifact called creds. The compilation model center that is called creds. What? Cred is a unit of compilation and linking, as well as versioning, distribution, and runtime loading. Cred contains a tree of nested module scope. The top level of this tree is a module that is anonymous. From the point of view, okay, the Rust compiler is always invoked with a single source. Its source file contains a sequence of 0 or more items within a way of begin with any number of attributes. Okay. All right. Okay, the how do you call this? It's not the question mark, right? The acceleration mark. Yeah, the exclamation mark. The exclamation mark is actually the macros to define how to give a comment to the Rust compiler. So we have this, maybe this one to give some semantic rule. Wait, or to define some linter for the compiler. Wait, that may be applied cred level. This is by the name of the thread with the meta name value str. Okay. Still didn't get it. Yeah, it's actually like a rule that run by macro to give a comment to the compiler. There is a many rule about that. Oh, identifier. Except create, solve, separate, solve. Maybe it's called the rust identifier. Identifier codes. What? Okay, macro, anything invocable as like exclamation mark. Okay. Oh. Oh, so it's called the attribute. It's general freeform metadom that is interpreted according to the name and a compiler version. So we can give okay a general metadata applied to the enclosing module or crate. So these attributes we can define this with the hashtag, also following by the macro, and then we can define the command for the compiler. So another example, we can a function mark use as a unit test, and then a conditionally compiled module. So there is it's actually many function with this attribute. This attribute can we can use this as the general metadata, and then we can mark some function, or we can conditionally compile module, and then we can use as a linter attribute to suppress a warning or error. Okay, problem solved. So the WSEM bingen is actually to define this extern to as the using the attribute of the mark this as WSEM bingen. So what is the extern actually? extern extern. Okay, if a law of providing function definite can be called with a particular API. Okay. We have extern in here with nothing in it. Uh, they are often used in combination external block. External block. By default, external block assume that the library they are calling use the standard C API. Oh, we have the external block in here. The external block that it will be used by the library WSM engine, and we will going to just make an alert with return of the S by itself. We have this as variable. It will be held by with the type data of the string. We define that as the str. Okay, so it is called the variadic function. Okay. Um, so this is called the attribute. What it do is actually doing the where the part of that function mark it as the unit test. So we are mark the extension block as WSM engine. So we have the extern C in here. Oh, do we? Oh yeah, extern C. It's supposed to be extern the C in here. as told by the external blocks, extern C is the same as the extern event function foo, whatever the default your C compiler support. So it's actually extern the C language support. Extern external block. Um, this is the same as whatever the default your C compiler support. External block that the library they are calling use the standard. To call the external library using DC compiler support. Okay. We just simply using the function alert with the written by the string itself. All right. Going to put this in here. Reference and this one reference for the attributes. Right. We need to understand about the variable itself. Variable. With using this one, I'm going to search with this an attribute. How do you call this symbol? Ampersand. Okay, let's see with the ampersand symbol on the Rust. We already done with item, pattern, type system. Okay, we got the variables. No, not this one. On the Golang actually that is called like call the str memory. Okay, we're going to googling this ampersand symbol Rust. Okay, there is a 36 meaning of the ampersand and star symbol in. Okay, a reference is like C++. It's not the same. It's much clearer in usage, not in semantic. Okay. Thread is implemented. See the bottom document for the following. Okay, this is just a convention thing that std will leave. Whatever. Oh, right. Oh, so the second attribute is no longer distributed Rust documentation. Mm. Oh, it's actually called the mutable type. You just simply define this as mutable. Okay, next one. We are going to also define this with the mark WSM Bingen. So I assume we are going to using the library of WSM Bingen in here, and then we are going to type this. We are going to make a public function with a simple greeting with name, and then using the type str string, and we are just simply use the alert and then with a format ampersand format format exclamation mark, and then using the hello, and then we're going to use this with formatted string. Okay, simply like that. So the alert we are going to call this alert because this alert is using the C compiler, and then we are going to use the format just simple. We need to mutate this macro function and then simple running the name. Well, where is the name? Oh, this one is name. We are going to create this. Okay, that's it. This content of our using the WSM engine to communicate between Rust. Okay, here's okay. This is there is actually a description about this. Okay, library are called the creds. Oh, so the library are called creds in Rust. This is a good point. Get it? Cargo ship creds. Okay. The first line contain use command which import code from the library into your code. Okay. This in this case, we are importing everything. Wait a minute. I'm going to change the color. A background color. Okay. Going to change this to this one. Okay, before we move on to the next session, we shall talk a bit more about WSM Engine. WSM Page uses WSM Engine, another tool to provide a bridge between the type of JavaScript and Rust. It allows JavaScript to call a Rust API with a string. It allows JavaScript to call a Rust API with a string. Okay, so it makes sense. So in the future, we can call any Rust function or Rust API with just simply using the string, or a Rust function to catch a JavaScript exception. Okay, we use a WSM engine function in our package. In fact, that's the next session. Okay, this is good. The bit inside this is called attribute. We are right. That is called attribute, and it modifies the next statement somehow. Oh, so it will modify the next statement. Okay, this is pretty powerful. So this is, I always see this on the Rust script. It's actually modify the next statement. The attribute mark the extension block as a button, and modify the next statement. Modify the next statement. Alright, which tells Rust, in this case, the statement is extern, right? This is extern. Wait, there's actually nothing in it. I just see this somehow with the C on it. Okay, we need to remove this. Right, we save that. For the next part, the third line, okay, which tell us that we want to call some externally defined function. The attribute says WSM engine know how to find this function. Okay, so we need to give a statement to the WSM engine, so there is a function that you can call in any time. The third line is a function signature written in Rust. It says the alert function takes one argument, a string name as. Okay, as you may suspect, this is the alert function provided by the JavaScript. Why? Why this is actually alert function provided by the JavaScript? Yeah. Actually, it's pretty simple. We only need string and then return the string itself in the next session. Okay, whenever you want to call JavaScript function, you can add them to this file, and WSM takes care of setting everything up for you. Not everything is supported yet, but we are working on it. Please file. Okay, producing a Rust function on the JavaScript call. Okay, this is the final part. Once again, we see the attribute WSM engine. In this case, it's not modifying an external block, but okay, this means that we want this Rust function to be able to be called by JavaScript. Sorry, I think I need to zoom this a little bit. This function, okay, there are functions we need, but rather the function we are giving out to the world. Right. This function is named create and takes one argument, a string written by ampersand str. Name it then calls the alert function we asked for indexing block above. It passes call to the format macro. There is a format with the exclamation mark format macro which let us concatenate string. Simple. It's just simply a concatenate string. The format macro take two arguments in this case, a format string and a variable to put in it. Okay, this is a variable, this is a string, and then this is a variable to put in it. Right, so we can keep going on this. This is pass alert, so when we call a function, we will see an alert box with hello Steve in it. Now that alert will be, let's build it. Okay, so we already built that. We need to compile our code to WebAssembly first. To compile our code correctly, first we need to configure open this file and change its content loop like this. Okay, we are going to just follow it. Maybe there is some important part in here. Okay, we're going to change the cargo. All right. Um, we had some description in here. We will going to add some license in here, and then repository. I don't need that one actually. Um, okay, we found something new in here. We see they are using the lib. That is, oops, what did I do? Okay. That is called the cred type. We define the library type with the cdy lib. I don't know about that. Let's see if they are defined that later. So the next one we need to dependencies with the wsm engine with the version of the 0.2. Right. Okay. Fill in your own repository and use the same into that get used for the outer field. The big part to add is the package. The lib part tell us to build a city-wide version of our package. City-wide lib. Oh, so city-wide lib is build a shared library on C. We won't get into what that means in sort of for more console, the cargo and Rust link get documentation. The last section define the dependency in here where we tell cargo what version of the WSM engine we want to depend on. In this case, that is only 0.2 version, but not a 0.3 or above. All right. So we're going to build the package. Now that we've got everything set up, let's build the package, type this into the terminal. All right. So we've done this, and then we need to WSM pack build now. Okay. So actually we are going to install some of the package on the internet. We call that the creds, right? The creds. I'm going to get some water first. I'll be back. All right, I'm back. Oh, here we go. Before that, I think if you guys want to learn about this, I'm going to share the link. Here we go. Um, okay, we are done something in here. So there is like 47 seconds of compiling, I think. So your WASM package is ready to publish. So it's actually already published. So let's see the tree. Oh my god. Um, okay, so there's actually a lot of file in here. We're going to ignore the target actually. The target is not really important at all. Okay. So we have a new directory that is called the package source and target, but we still didn't know about which one that is actually used by WSM. Oh, I think I'm going to change the chat box with the color of blue. Yeah, I love blue. I'm going to choose the space first. Okay, good one. Oh, okay. Let's see the package. Here is the important one. So around the river, the we are built the WSM package build. There is actually we only need the package. So actually there is a lot of file in here. We have the hello WSM Java BG. I don't know what the background or something. GS WSM WSM.d.ts hello WSM.d.ts hello WSM GS and package.json. We're going to inspect this now. We are going to inspect the first file. This hello WSM underscore bg.js. Alright. A simple line of code that is actually convert everything in here. Okay. Oh, we have the grid one in here. This is the function that actually put on this JavaScript file. I think we need this one. So this is actually an API to call the the JavaScript bundle to call the Rust API with the string. Alright, that's it. We are going to read the hello WSM the underscore bg WSM, a gibberish file. But string hello, if we define, oh, is that strings? Okay, if we define to see some of the strings on the file WSM is actually like this WSM is actually will run this file GS, and we have the WBG alert that actually we see this before in the file GS. We have the memory, we have the grid function. There is maybe in the future we will call this function on the JavaScript file, and then we have the malloc and reload, memory allocation and reallocation. And the next one we have a simple hello that is actually formatted string from before, and then we have a simple language, and we have a bingen walrus. Okay, something like that. Let's see the ts file. What is that? Here we go. Okay, so it's actually a TypeScript file. Actually export some WebAssembly memory, and then memory allocation and reallocation. All right. What's the difference with the DTS? Hello.p. Same one is actually defined a Rust API with a simple function name with a string. So we will use this simple grid in the future. And what about this hello wasm.js? Okay, it's simple. So it actually imports the hello WSMBG or .wsm, and then export some JavaScript file. So we need these two important file if we want to run this wasm. Okay, so let's see again. This does, okay, compile your Rust code to WebAssembly. Okay, run wsm bingen on that assembly, generate a JavaScript file to wrap up the the WebAssembly file into module npm can understand. Okay, generating a JavaScript file that wrap up the WebAssembly file into a module npm can understand. We need more like this. Okay, so next one, create a package directory and move the JavaScript file and your assembly code into it. Read your cargo XML and produce equivalent package.json. Oh, nice. So it will convert the cargo XML to the package.json. So copy your readme if you have one into the package. Okay, the end result, you have npm package inside the package directory. Okay, a digression about the code size. If you check out the generator, it may be 100 kilobytes. We haven't instructed Rust to optimize for size at all. Okay, never mind. We are going with the hello world actually, and doing so cuts down on the size a lot. Oh, this is pretty powerful. We need to make some remind in here. Any every time we are going uh, to generate a WebAssembly file, we need to think about with the code size. The Rust actually can optimize this. Okay, automation shrinking from the, okay, making our package available to npm. Oh, what? Okay, let's using the package on the web. Let's build a website that uses and we get written in Rust but compiled to, okay. We need to npm link now. What is the npm link actually? We need to use this sudo. What the fuck? Okay. We now have an npm package written in Rust but compiled to WebAssembly. Okay, let's move back to the package directory and make a new directory site to try this out in. We are going to go in here to the root directory actually. We're going to make some site in here. We're going to the site and then npm link hello wsm. Oh, so it will link our the WebAssembly file. Create a new package and put the following code. Theme package.json. Oh my god. I'm sorry. I'm going to use this. Package.json. Oh wait. I'm going to use this package.json. Here we go. We're back at the server. We're using the hello wsm define dispatch. Okay. Next, we need to configure webpack. Create webpacks config.js and put the following on it. Okay. Is it? Oh, I'm sorry, the GS. Oh, here we go. The webpack configuration. We need to require a path, entry with index.js, output index.js, and the model development. Okay, easy. Now we need the HTML file created by index and give the following contents. We are going to create the index. Here is a simple index, so we are going to call the index.js in here. Okay, finally create the index.js reference in the HTML file and give it this content. Oh, here we go, the important one. Here is the important one. We're going to create the index.js. So we are going to import the node modules, hello WSM and hello WSM.js. Okay, actually we can easily just use this on the local directory, but with the npm package link is much better, I think. And we import this as JS if success, and after that we need to create a WebAssembly. Hello from Kimochi. Note that you need to fill in your npm user again. This import the new module from the npm node. This isn't considered best practice, but it's a demo, so it's okay for now. Once it's loaded, it's called the create function from module. Passing okay. Alright, so we only need to npm install. Okay, I had npm install. Going a little bit explore getter the town. There is actually a good application in here that is called the go getter town, where there's space to get around. It's like virtual office. Let's see where the oh. So actually we can buy we can make the town city or metropolis. This is pretty good. Free chair accommodation 25 online user. Right. We've done that. No, it's still going. All right. Here we go, the result. Hello from Kimochi. Let's see the process of the file. We got to clean this up first. We're going to refresh this. Hello from Kimochi. WDS live reloading enabled. It's actually from the npm. So we have WebSocket in here. What is that for? Oh, it's live reload. Oh, here we go. Here is our WSM module. Here is our WSM module that we get it from this index.js. And then a bad magic number. So that's it. We are complete with hello world. Yay! It's like almost like 1 hour. Okay, so right now I think we need to define the task for the our project. Now we're going to make a new label in here. A label, let's call the WebAssembly. Wait. We need to create clear search, show a label. We need to add a new label. How to add a new label in here? How? Oh, here we go. Create a new label. We're going to do with the webasm blow, motherfucking blow. We are going to search card with the WebAssembly. Okay, it's much clearer now. Let's create the task. We're going to make an epic right now. The epic is create the faster Jogja item. Okay, this is the epic one. So we need 3 separate tasks in here. Backend Rust with WebAssembly, and then we are going to front end with React.js to list a groceries list. Wait a minute. Okay, never mind. So we have backend Rust with WebAssembly. Okay, backend Rust with assembly. It's actually have a child of task. Because we have the offline first at the end. We can build the well, should I make the offline first in the beginning or the last? Backend Rust with WebAssembly. So let's see. We need to create the concept of the offline first itself, we need to load the data first. It's like load all of the data. But this offline first is working on the front end. So what's the point to making the WebAssembly this one? Oh, to process the file itself, I think. Okay, we need to think about to store the database. Uh, Offline first database. Okay, we have the Hasura in here. Uh, okay. Okay, we need to making a code available offline, making data available offline. So we have a device one and the device two, we have a local database, and then we have a backend service. Uh, we need a list of MVP first. Wait, the user is actually what they will do with the application itself. Okay, how might we make the user can access the groceries list available offline? This is really hard. Mm, Not that one. That's have a lot of subtasks again. Backend transfer or something. Okay, let's just use this. And then next one, how might we made made the users can watch one of the item, one or many items. So when the price change will be notified. It will be notified. Okay, actually this is too perfect to be built. It looks like it's too perfect to be built. So I think I'm going to use the offline first library on the React. Offline first React, yes. I'm using the Redux offline. Where is it? Okay. Actually, Advisory already have the offline first library. Let me see. Send notification when price as discount via email may be good. Okay, cool. Going to use this. How might we send it when the price is discount via email? Maybe good. Okay. I don't know if anyone still using the email as the notification, but let's see if we can use the notification via email. That's a 3 bigs of the MVP. Wait, we need to create another MVP. Wait. Make the user can access the groceries list available offline. Make the user can watch one or many items, so when the price changes, it will be notified. How might we tell the user if the data is actually not updated? So the concept of the offline first itself, we need to compare between the data version. So if the data is actually not updated, the user will not get any notification. So why offline first again? So actually we are need to using the offline first, so we can to explore the the groceries list offline. Because whenever we are going to access the jogjaonline.co.id, we need to have a request and response to the server. Every time we need to communicate, we need to see some detail of the file, or we need detail of the groceries or anything. Backend Rust with WebAssembly, and then we have the front end with React.js to list a groceries list. It just simply we made a better version of the jogjaonline.co.id or alpha card or the click in the mart. All right. Um, okay. This one have the this one, and also this one, and also backend Rust. Here is the MVP list. This one, the MVP list. We're going to delete this. We don't need that. We already create the HMW. We are going to create the MVP itself, minimum viable product. We're going to attach some card. All of the HMW. What? Make. Wait, what? That's pretty annoying. Let's just sit like this. Here we go. We have to tell the user if data is actually not updated, send notification when price is discount via email, make the user can watch one or many items, so when the price change it will be notified, make the user can access the groceries list available offline. The best one we are going to do is build the backend that will be served. We need one another card. How might we create the database with offline first support? Okay. Oh, let's see the adversary directory. We have the Pouchy store, the library to its Pouchy's couch stack on offline first app. Okay. we can use the MongoDB or any document based database. Oh, this is where the scope of the enable is to take the percent background processing. Okay, so we need using the service worker to background processing. Oh, we need the indexed DB, indexed database API. So it actually will be stored on the web storage. Oh, it's using the PouchDB. It's still using the PouchDB. Oh, we found the local storage in here. It's offline storage, improved wraps indexed DB, web SQL, or local storage using a simple but powerful API. This is pretty good, I think. All right, this is a good one. Oh, we have this website of the offlinefirst.org that actually comparison of the, oh, this is pretty good. I think I'm going to put this in here. Also this one in here. And then this one in here. Right, neat. We have this CouchDB replication protocol, config resolution strategy, determination chosen winner, developer supplied strategy, selecting from a revision tree conflicts. With the client implementation with the PouchDB, cloud and mobile sync, and Couchbase mobile. Of course, we are going to use the PouchDB if we are going to use the CouchDB replication protocol. Okay, we're going to note that first. So the next one we have the Realm sync engine. Conflict resolution strategies like last right when updating or deleting object. Okay, so the offline first is actually a pretty tricky storage of the system that actually with the difference with the CouchDB and Realm is last right wins. So the very first problem with the offline first is also talking about the conflict resolution. So with the Realm sync engine, if we have a two-person, let's say this person A and a person B, that actually edit the same data that we call some same item with the same index ID. So the one person is actually change the price, how do you call it? The price information of the item, and then the second person is actually updating the name of the item. So if we are using the conflict resolution of the last right wins, it means which person that actually update the data last. So if the person update the data last, so the next person, the previous person will, the case in here, if both person is actually write the data on the very same time on the same second. So actually the last write will win when updating or deleting object. Okay, the next one this one appending item when inserting into list. Okay, what is called the dirt deterministically chosen. Um, okay, it's like some. Oh, there is a footnote. Okay. Working with the conflicting document, the basic will show. Okay, if you do set, then you will get the winner plus a conflict member containing an array. Oh, so they will made a version of the conflict data, and the original data it will be saved, right? This is good. I think the best one is still with the CouchDB. We have the Firebase real-time database. Oh, this is one of the famous database. We are using the Firebase real-time database. Last write wins when using the set or update a pending item when using push. Developer supplied strategy when using transaction. Apache CouchDB implementation will maintain a revision tree of conflicted document, allowing for the selection of a document or the merging document data using application logic. Okay. Yeah, we're going to using the Apache CouchDB. What's different with local forage? What about the conflict strategy with the local forage? I don't see anything on it. It's nothing in it. We're going to using the CouchDB replication protocol. This one are much better, I think. We are going to client implementation with the PouchDB. What is the difference with the advisory have one? Pouch store libraries to is pouch couch stack and off on offline first. Okay, we're going to use this one, I think. Um, so we are going to use the pouches store. What the difference with the PouchDB itself? Mm. Mm. Oh, it's like a set of the pouch DB is actually working in the pouch store, so we don't need to think about the sync, I think. We are going to explore this pouch store later, but let's see if we can use the pouch DB itself. Right. Um, we're going to make using the pouch DB as the client implementation, using the couch DB as the remote database. And then what else? Um, okay, I think we need to convert all of our data on this Bibit into the good version one. But actually, I already create something in here with the Bibit. There you go, data. We already made the document structure. I think we need to change. We need to import all of this data to the CouchDB. Okay, so we need to change one of the file. Wait. Okay. First thing first. We design the DB of the CouchDB for Bibit, and then we need to migrate all of the data to CouchDB. So what next? After we design that, we need to migrate all of the data, and then that's it. All right. Testing the implementation of the pouch DB. Okay. That's it. We just simply will doing this later. After that, we are going to make how might we make the user can access the groceries list available offline. Uh, this is much more like on the front end. Um, Working with PouchDB for the offline first support, and then design the front end is just simply the search box and a list of items. The next one, after the design the front end, we need to implementation of the design to the React.js. Okay, for the implementation of the design to the React.js, we need to specify this much detail. because I'm not an experienced front-end engineer. So I think I'm going to make a very tiny task for us for achievable task. First thing first, um, after design, we need to implement the home page. Um, so for the home page, we need the search box, we need the item box, and then for the next one, we're going to implement the uh, item detail. Implement the item detail. So with the item detail, I think we will make the a simple description, or I mean a description about the item with the current price. The camera is not synced. Oh, wait, I think I'm going to deactivate first and then activate it. I will implement the item detail, a description about the current price, a description about the item, and a simple analysis analyze analysis wait, this one, right? A description about item and a simple analysis with a graph, a change price every date, simple like that. With average of the change price, this will be good. After that, we need to create the implementation of the watch item with the star button. If activated, it will be send a notification. I think we're going to with the browser notification or email whenever. Okay, input of the watch item with the star button. Okay, it will be on this part. With the star button, it will be send notification when the price is changed. Simple like that. About this one, we are going to add like an item implementation of the watch item with the star button. If activated, will be sent a notification or email when the price have a discount. I mean a real discount. Why did I tell about the real discount? Because if we have a history about the change price, we supposed to be know if the price is actually decrease or increase. Because sometimes maybe the Jogja Online or the Alfamart will never tell you about the price is actually much cheaper now, because maybe they have a good strategy about it. Tell us if the data is actually not supported. So I think I'm going to add a new checklist in here that is actually called the offline first serve support with trick marketing for discount. Yeah, really right. Trick this marketing for discount. Offline first support. Whenever the data user is not updated, it will get a latest data. So we also need a version of the data itself. how do we define this? Maybe, uh, okay, we need to define the data version algorithm. So whenever every time we get the data, we need to give the current version of the data, so the client will understand if the data is actually updated or not. Okay, if we talk about the offline first, the page itself is actually will be cached on the client browser. So I think we need to implement one of the crucial function. We can call this how might we tell the user if the application is not updated and needs and update the application. So actually this is a common problem on the offline first that actually I always facing on the advisory. So the problem is maybe it's like some of the client is actually not active, or they are maybe on vacation for a month, and we already updated like 2 versions ahead, and the client is actually will be complain about the function is actually broken. It will be have a broken change actually. So the client will be complain about the breaking change, and we will also confuse about the web apps is not updated on the client. So I think we need to make how is it called? What is it called? The version web application version checker. So it just simply whenever the version is not updated, it will be show a simple, how do you call it, a simple model box. It will show the application is not actually updated, and uh, the application will tell the browser to delete all the cache and then reload the application in the hard way, so it will be on the latest version of the application. That's it. All right, we have a big project comes. We have a big MVP in here. So which one are the good way to doing first? We will of course start with the database with the offline support. I think we need to arrange this. We made this for the first, and then the second one, tell user if the data is actually not updated. The data is not active updated. Okay, so this is the second one, and then we are going to make this the third one, and then let the user can watch one many items, so when the price change will be notified. So this is the number 4, and then this will be number 5. This will be a big project for me. I think this will be lasted for a whole month, maybe 2 months, but hope this will be a good application implementation for the WebAssembly. Oh yeah, I forget about the WebAssembly. Where do I should I put the WebAssembly? Um, on this part. Tell the user if the data is actually not updated. Okay. Offline support, whenever the data user is not updated, it will get the latest data. Use the WebAssembly to sync. So wait, if we're using the WebAssembly for to get the latest data, so it will be good. or we just need to keep, oh no, no. Well, we need to put the WebAssembly in here. We can use the WebAssembly as the processing of the storage file. Okay, okay, we can use in here implementation of watch item with WebAssembly. We need to note this with a WebAssembly. Okay, we also need to use this with the WebAssembly. Oh no, no, we don't need this. We don't need this also with WebAssembly. We need this working the PouchDB for the offline verse support. PouchDB WebAssembly, is there anything about that? Tabletop RPG experiment. Wow. Oh, there is actually someone that already implemented the WebAssembly with Rust and CouchDB. I think I'm going to check up a little bit up with this one. Okay, which part of the function is actually have a long of the process? This one working with the PouchDB for the offline for support. Let's just think this. We need to set this up with the WebAssembly because we need to have a conflict. Oh yeah, we need to. I think it will be best if we made a conflict resolution with the WebAssembly. But let's think that for later. But we're going to note this working with the PouchDB for the offline for support with the WebAssembly. And then this on the front end is just simply search box and list of item. Okay, we need to list of item with WebAssembly because this will be a core function. So the process will be much better, faster. Do we need to make a recommendation? I mean, the how do you call that? Um, there is a search box, so whenever you type something on it, it will be show a new recommendation. Yeah, a recommendation box. I think, yeah, search box. If recommendation box. And a list of item WebAssembly. So we can use the recommendation box with WebAssembly because this will be much faster because the data is actually already in the offline state and we can get that on with the WebAssembly. Implement the webhook, okay, just simply usual design. Implement the item detail. Okay, this one also we are going to use this with the WebAssembly. So it will be much faster to render off the data and then render the graphic itself. Oh, I'm very happy that we can implement the WebAssembly a lot more in here. Okay, this is a common with the PWA or the service worker. Okay, here we go. We're going how to do it if the application is not updated. The application, okay, we are going to put this on the last section. So we have a 6 MVP in here. First one, we need to create the database with the offline support. And then the second one, we are going to tell the user if the data is actually not updated. And then make the user can access the groceries list available offline. And then make the user can watch one or many items. So when the price change, it will be notified. And then the last one, tell the user if the application is not updated and update the application. Okay, so I'm going to do all of this. It will be my big project for like 2 to 3 months. But my focus on this week is actually about the WebAssembly. So wait, I think I need to make label this with the WebAssembly. I think I need to change this with the WebAssembly project. Save. So on the Twitter, actually, there is someone mentioned me about usually when you are going to stream on the live code, and actually here is my schedule, maybe schedule for now on. I think for tomorrow, this will be tomorrow, right? This will be tomorrow. I'm going to continue to WebAssembly, Rust, and React, but we still don't define what we are going to do for tomorrow. But the best part here, we are going on the Friday around 8 night. Uh, we are going. I'm going to present about the WebAssembly on Bahasa. So everyone, I think I'm going to use the multiple streaming on the Facebook, WhatsApp, and YouTube. I think I'm going to telling people about the understanding about the WebAssembly with the Bahasa. Actually, preferably with the Rust and React, and how to use it, and what is good, and then this Bibit project will be a good example for the Rust and React. Okay, wait a minute. Okay, we already defined all of the project we are going to go now. So for tomorrow, what we are going to do? Okay, I'm going to put a note in here. Day to learn what we are going to do now. The best way to calculate of the okay. Yeah, the main focus of the WebAssembly here, we need to tell about the a good way to understand about the um, WebAssembly. There is a website that actually running on the WebAssembly. Here we go. And also, I think I'm going to use this presentation as my reference. So for the in the Friday, I think it will be much like a tech talk for me. And right now I'm going to prepare that. I will turn. Oh, there's a game of life of this. Mm, now we're going with the file converter. This is a very good example with the Rust. We're going to explore the file converter, and then with the Boy, and then the OGV. So for the next goal, what we are going to do now, we need like a very little project that I can build for within a day of stream. Shall we create a game? Oh, um, no. Oh, really? One Password used WebAssembly to speed up their browser plugin. Going to explore everything with with WebAssembly, and we are still working on which a simple project that we can use to met with WebAssembly. Oh, there is a pathfinding with WebAssembly. Um, what kind of project that I can build from the scratch to really understanding about the WebAssembly. Let's see. I believe this Gather Town is also using the WebAssembly. Okay, I think I have a three option. First one is I think the first one we can choose like parsing big data from file parsed by WebAssembly, and then the next one. Hmm, yeah, actually, we need to understand about what a WebAssembly actually for. It's not like everything we need to make it with WebAssembly. There is some specific as we can really that the WebAssembly is pretty useful. Okay, so the next one, I think we are going to using the file converter. We are going to specific check of the file using the FFmpeg. Uh, oh, mm, Mm. Mhm. The best one I think comes so far with the file converter. Oh, how about the grab? Crypto, ultra resolution image viewer, and storytelling tool. Everything about the web assemblies is actually with concern of the actual desktop application that is simulated on the. It's actually not simulated, actually ported on the browser. It feels like the browser is actually an operating system itself. This will be good. I love Doom. I love Doom. It's a Doom tree. Yeah, I think I'm going to explore everything in here, and we are going to build a simple WebAssembly presentation with the Bahasa on the Friday. I hope everyone can learn about that, so anyone will be interested with the WebAssembly. And I think I'm going to make it much more like simple possible, so everyone will never think about the WebAssembly is actually hard. It's actually pretty easy. Now, how about the file explorer? No. Okay, but I think that's it. For the base choice, for the example, I think we are going to parsing a big data from file, parsed by the WebAssembly, and then the next one we are going to use the file converter, and we are going to explain the code itself um, one by one. So yeah, that's it for today. So what I think I'm going a little bit review for the last we're going. So our goal is like create a faster Jogja item groceries list with WebAssembly, of course with the Rust and React.js to build the offline first web application. And for the Rust itself, we learn something with the Rust. We are using the Rust as the compiler. We are the cargo as the Rust package manager. Also, the library is not actually called the libraries in here. They called it the crate, right? So for the WebAssembly package, we are going to use the WSM pack on the Rust. We need to install that, and then after we are going to write some code in it. We are using the WSM bingen to generate the JavaScript file and the WebAssembly file, so we can call the file the WebAssembly with the string API. So my main focus on the WebAssembly is most likely on that point. I think I'm not going to tell further about the WASI for the deployment of the WebAssembly. So it just simply I just put that on the internet and everyone can access that file. Simple like that. So that's it. So yeah, I think pretty that's it for today. So I hope you like it. Thanks for everyone that's also watching this share this stream actually. Thanks for Wheeler Cup that always keep staying on here and talking with me. And I believe you are still in here right now. So thank you so much for still watching this. And yeah, for the next moment, maybe tomorrow, it's pretty tomorrow, like today, I think I'm going to more explore the WebAssembly with the trying some of the tool of the WebAssembly, like file converter, Fiberboy, OGV, and the Doom 3 WSM. And then with the two main goal, the first one with the parsing a big data from file parsed by the WSM, and then the second one we are going to using the file converter itself with the example from the GitHub. So that's it. Um, I'm going to live again on the 9 p.m. on the night. So thank you very much for everyone that's still watching me until right now. So let's keep on with working with this WebAssembly tomorrow. So thank you everyone.